Clue! Cellular Respiration Edition!
What?
This is such a fun party.
Yeah, thanks for inviting me.
It's not my party. Where's Miss Peacock?
She's dead.
What happened? I don't know!
Who did this? Where's the murder weapon?
We must solve the mystery.
By golly, I know. We have to follow the map. Let's start in the hole.
The most amount of ATP must be what the murderer used to kill Mrs. Peacock. We've arrived at the hall of cytoplasm, where glycolysis takes place.
Here we track 2 ATP and 1 glucose, hoping to find more ATP.
In glycolysis, we break the glucose down into 2 pyruvates so we can fit it into the mitochondria, just like we break it down at our parties.
Okay guys, let's break up and look for clues, also known as outputs.
By golly, I found 4 ATP over here, but 2 of them were the ones we tracked here, which makes it a net of 2. There's also 2 NADH and 2 pyruvate back here.
2 ATP is not enough to kill her. I know, we should follow the pyruvate and head to the lounge.
I've been expecting you. You arrived in the lounge where pyruvate oxidation takes place. It's also known as the mitochondria.
You know the drill. Let's look for clues.
The pyruvate we followed here is being broken down into acetyl-CoA through oxidation.
So we did not find any ATP here, but we did find 2 NADH, 2 acetyl-CoA, and 2 CO2s. The murder weapon is definitely not in here.
Let's follow the clue of the acetyl-CoA into the kitchen.
Welcome to the kitchen, also known as the citric acid cycle, also known as the Krebs cycle, also known as the tricarboxylic acid cycle.
We followed the acetyl-CoA in here, but we're still in the mitochondria. We must find the ATP murder weapon. What's that over there? Follow that clue! I haven't put this much energy in years!
I just make a deal.
Okay.
Oh no, crop! The lactic acid is building up through fermentation.
After going around the citric acid cycle, we found 2 CO2, 1 FADH2, 3 NADH, and 1 ATP per acetyl-CoA.
That's not enough ATP to be the murder weapon. We have to go to the library.
We have entered the library where oxidative phosphorylation takes place.
The labyrinth of these bookshelves is like the cristae, the inner membrane of the mitochondria.
We followed the NADH and FADH2 along with the oxygen, ADP, and inorganic phosphate.
So all we need to do is follow the NADH and FADH2 through the electron transport chain. This will create a gradient that ATP synthase uses to convert ADP and inorganic phosphate. This will create the large amount of ATP. Of course, oxygen is the final acceptor for the last electron, but this will help us find the ATP murder weapon.
After searching the electron transport chain in the library, we found water, FADH, and NADH+. And all of the ATP is headed towards the ballroom, which must be where the ATP murder weapon is.
We've made it to the ballroom, which is our final destination.
There it is! The ATP murder weapon!
We still don't know who the murderer is.
Most certainly, who did it?
It was me, okay? She was so annoying. I had to find a way to shut her up.
Mrs. White, how could you?
So you're telling me it was Mrs. White in the ballroom with approximately 28 to 32 ATP?
Precisely.
Arrest her! You have the right to remain silent.
I guess it's an American thing, now that I think about it.